Hello, welcome to Hawk Math. Today we're going to be doing the 2015 AIME 1 problem number 12. Now this problem reads, consider all 1,000 element subsets of the set 1, 2, 3, all the way up to 2015. From each of these subsets, choose the least element. The arithmetic mean of all of these least elements is p over q, where p and q are relatively prime positive integers. Find p plus q. Let's first try to figure out an expression for what this is. Well, we know it's the arithmetic mean, and so the denominator is going to be how many numbers there are. Well, how many least elements is just how many subsets are there of this set with 1,000 elements. Well, the amount of subsets of 1,000 elements from the set is just going to be 2015. Choose 1,000, because you're choosing 1,000 subsets from 1,000 numbers from 2015, and that's the amount of subsets. Now the numerator is going to be the sum of all the least elements. So how do we figure out how many least elements there are, and we need to add them up? Well, one way to do this is we can see if we were to set, we want 1 to be the least element. How many subsets have 1 as the least element? Well, that's going to be, if you set 1 to be the least element, there's 214 left, and we're choosing 999 of them. So we have 1 as the least element, and then we have 2014 left, and we're choosing 999 of them. Well, now how many subsets have 2 as the least element? Well, we chose 2 as the least element, and now we have 2013 left, but we have to choose 999 of them again. So now we have 2013, choose 999. And if you see, this pattern will keep increasing. We have 2014, choose 999, and so on, all the way up until we reach the end. Now, when does this end? Well, we know we want to find, we're going to be choosing 999 elements, but how many are we going to be choosing from? So when we get to the end, we're going to have 999 left to choose from that still be valid. And if you notice, these must add up, this plus this must add up to be 2015 for all of these. This coefficient is going to be 1016. And that's all we have. We now need to evaluate this and set it equal to p over q. Well, how can we simplify the numerator? My first thought is that I noticed this pattern of decreasing, and it reminds me of being able to use the hockey stick identity, but we can't immediately use that because we have these coefficients. So let's try to think of it in a different way. Well, I see that if I write this out creatively, I can write this as 2014, choose 999, plus 2013, choose 999, plus 2012, choose 999, and so on, up until we get to 999, choose 999. And the reason why I want to write this, obviously I'm missing out on this 2, this 3, this 4, and so on, but I'm able to evaluate this easily using hockey stick, which we can get to later. Now, what do we have left over? Well, we have this left over, and this left over, and so on. So we could really write also a plus another 2013, choose 999, plus another 2012, choose 999, and so on, up until 999, choose 999. And again, we now need to add another one of these. So we have a plus 2012, choose 999, and so on, up until we have a plus 999, choose 999. And this pattern will keep going. We can keep adding more until we finally get just a straight up 999, choose 999. And if you notice, if we were to add up all of these, we would be left with what we originally wanted. So now all we need to do is just evaluate each one of these. So in order to do this, I'm going to quickly write out the first years of Pascal's triangle to show you hockey stick identity one more time. So if we wanted to add up this and this, their sum would be this one. So, and if you notice, this is the same thing as 1 choose 1, and this is 2 choose 1, and this is 3 choose, and that is equal to 3 choose 2. So if this bottom is staying constant, all you do is you increase the ending 1 by 1. So this is equal to, well, if we increase, we have it written backwards, but if we increase this one by 1, we'll get 2015. Since this is being increased by 1, we also increase the constant by 1. So that's going to be it's going to become 999 plus 1, which is 1,000. This part right here, well, we see the same way is going to be 2014, choose 1,000. And this is going to be 2013, choose 1,000. And so on, up until we get, well, this last part is just going to be same thing as 1,000, choose 1,000. And that it's pretty obvious because this is just 1 and that's also just 1. So now what we need to do is we just need to add up all of these. Well, again, this is another hockey stick. We have this constant down here, 1,000, and this is increasing by 1 all the way up to 2015. So all of that, when we add those up, is just going to be equal to, I'll add a plus sign in there, and that's just going to be equal to this increased by 1, choose that increased by 1. So that's just going to be equal to 2016, choose 1001. And now we have a really nice way to simplify this. So this whole fraction is just going to become 2016, choose 1001, over 2015, choose 1000. And this is really easy to simplify because all we need to do is just write this out. So 2016, choose 1001, it's going to be 2016 factorial over 1001 factorial times, we take this minus this, and that's going to give us 1015 factorial. And then we have times, on the numerator here we're going to get 1000 factorial, and then we're going to get on the denominator 2015 factorial, and on the numerator again we're going to get 1015 factorial. And we notice that this cancels with this cancels with this, leaving with just a 1001, and this should be 2015, my bad. And then this will cancel with this, giving us a 2016. So this whole fraction is equal to 2016 over 1001. Now, simplifying this fraction, I know that 2016 is a multiple of 7, and that 1001 is also a multiple of 7. So this is the same thing as 288 over, well, 1001 divided by 7 is going to be 143. Now, I do not believe this will reduce any further, so all we need to do is sum up P and Q now as a problem mass, P plus Q, and that will give us 288 plus 143, which equals 1, carry the 1, 13, carry the 1, 431. And that is our answer, and we are done with this problem. Thank you for watching. I really hope you enjoyed. So the way we solved this problem is we started by finding an expression for what we wanted to find, and we realized we could simplify it down through the use of hockey stick creatively. So whenever you have this 1, 2, 3, all the way up to some number as a coefficient for something that looks like hockey stick, you can rewrite it like this and just use it twice. And I like to call this double hockey stick, and I find it pretty neat. So please like the video if you enjoyed, and subscribe if you want to see more.